Hello everyone, I'm Catherine Laing. So I'm as well, thank you for the lovely introduction, James. I work on developmental linguistics. Today I'm going to be talking about a paper that was recently published in the Journal of Child Language. This is a paper that's, I'm one of the authors. We've also got collaborators from Newcastle and other academics from York on the paper. And the paper is entitled Size, Sound Symbolism in Mother's Speech to Their Infants. The reason my talk is called Iconicity Revisited, I'll just move my little, I'm kind of in the middle of the slides, so I'll just move me out the way. The reason that my talk's entitled Iconicity Revisited is because I've actually given 2 previous talks at the Toolkit events. So if this is a topic that's of interest to you, then there are resources from previous years. I also just really like coming back because it's such a nice event, so thank you for having me. So usually the way that I introduce the idea of sound symbolism is with a kind of replication of a really famous experiment that was introduced by Gerhard Köhler in the 1970s. Köhler presented participants with 2 shapes that I've got on the screen here. You can hopefully see them too. Well, you can see them too. And asked participants to decide which of the shapes is a booba and which is a kiki. So let's have a go at this experiment. Which shape do you think is a booba? Which one is a kiki? 2 boba, 1 kiki. Thank you. So I don't know if anyone disagreed with that number 2 is the booba, number 1 is the kiki. If you did, you are in a very, very small minority, because pretty much everybody who's done this experiment, I think 95% of participants would agree that number 1 is the kiki and number 2 is the booba. So there's something spiky sounding about the word kiki and something round sounding about the word booba. That's been shown across people speaking all different languages, and also from babies as young as 4 months old. So it seems to be a trend that's just replicated really consistently since the 1970s. This is called sound symbolism, which can be defined as a systematic relationship between a linguistic property and a meaning, should I say. A linguistic property and a meaning, that should say. So there's as I said, there's something spiky about the word kiki, something round about the word booba. We might, so I'll come on to this a bit later, but we might say that this could be an innate bias if babies as early as 4 months can make this association, if people from all over the world speaking all different languages make this association, but we'll talk a bit more about this later. I just want to plant that idea there, and we'll talk about the theoretical implications in a few minutes. But we're going to start with an activity from you. I hope that you're feeling awake this morning. So I'd like you to get into pairs. This is actually from the lead-in task in the materials provided with my talk. And I'd like you to pick one of these animals. If in your pair you could each pick a different animal and tell each other a little bit about your day. So if you could do that just for 1 or 2 minutes, and then we'll come back and we'll discuss what you did as that animal. So go ahead. Okay, I don't know how far everyone got with that task. Did anyone have any, so the thing that I'm looking for here is voice related. So the kind of properties I'd be looking for are voice related. Did anyone change their voice when they were the animal in question? Was anyone feeling really into the activity? Okay. And which animal did you choose, and what did you do with your voice?
I chose the mouse, and then made my voice very little and high-pitched and tentative.
Excellent. That's the answer I was looking for. So thank you. And how about you? Did you?
I looked at the cat, and I kind of moved my arms. I was thinking about the cat would be spread out on the sofa. And maybe more sophisticated. The cat wandering next door and getting some food.
As a cat lover, I appreciate that answer too. Yes. Excellent. Did anyone notice any patterns then in the way that they used their voice? If you did get into the role of the animal. Yes.
I think I repeated very short sentences over and over at a much quicker pace.
Okay. Which animal was the dog? I was thinking that might be the dog. Okay, this is good. This is all good. This is good data. What kind of dog would you have been? This particular dog, I don't know what that is.
No, I'm thinking my own dog's little
Little
Havanese, so they're quite excitable, spooky little things.
Okay, yeah, that's good too. Thank you. That's really helpful. Okay, anyone have anything else they want to add? Because the next one is similar, but it's maybe something that you haven't come across before, some kind of weird alien thing. We had a few discussions about what actual creature this might be. So maybe, again, another minute, and one person be this creature and one person be the other creature. And this time try and embody that creature. What would that creature sound like if it was telling you about its day? Okay, I'll stop there again. Sorry if you were having a great time being one of these creatures. But my question again is, what did you notice? Were there any sort of differences between you being this creature and you being that creature in your pairs? Yes?
Like a deep voice for the right-hand one.
Yes.
The ruler, the overlord of the alien race.
Great, yes. We are in a talk about language and linguistics, so voice is obviously going to be a focus here, and you've a spot on there that this one we might think has a deep voice. And what about the one on the other side? A high-pitched voice. Okay, excellent. So you've very kindly helped me demonstrate what we refer to as size sound symbolism. And this is, the way we would define this, it's a kind of a little extension of sound symbolism. So the first example I showed you of the booba and kiki shapes, this is where we have a systematic relationship between a linguistic property and a size. And so we would expect that a smaller thing typically would have higher pitched features maybe, and a larger thing might have lower pitched features. So we would make these sort of assumptions about the size of a thing and sounds that might relate to that thing. And that maybe sounds quite vague. A good example would be if we use the word a word to refer to something small like teeny or tiny. It kind of has small properties somehow, whereas something like huge or large, those words have big properties. So there's some kind of relationship, and it may feel a little intangible, but there's some kind of relationship between the linguistic property and the size. So this is a kind of sound symbolism relating specifically to size. Okay, so this is thought to potentially be useful in word learning, which is why this is interesting for people studying child language acquisition. So there's a theory called the sound symbolism bootstrapping hypothesis that proposes that sound symbolism, any kind of sound symbolism, might help babies or children navigate really complex speech stream. So language and the lots of different words that they hear every day, they somehow have to listen to a word and figure out what it means. And sound symbolism might help them figure out what it means. So if you think back to the first slide with the booba and kiki, it might be easier to learn words that have those kind of sound symbolic properties attached to them. And that might then help them learn other words because they've started to build a vocabulary. So it's called a bootstrapping hypothesis because the word bootstrapping refers to something that might be helpful in learning. So that's why it's got this name. So one of my favourite examples of sound symbolism, or actually some of my favourite examples of sound symbolism, come from Japanese. Japanese is actually really, really rich in sound symbolic words. There's a whole dictionaries dedicated to these words. So I've just picked a few nice examples here to demonstrate. And I guess I want to just flag up that, well, hopefully you agree with me that there's something about these words that sounds like what they mean. Even if you couldn't explain what that is, there's something about them that evokes the meaning. So, for example, pachi pachi relates to crackling, clapping, or blinking incessantly. Uzu uzu might mean itching to do something or being impatient. Goro goro is rumbling or the uncomfortable feeling of having a foreign substance in one's eye or stomach, or a large object rolling slowly. Contrast that, goro goro, with koro koro, which is a small object rolling quickly. So these are, I think, really, really interesting examples, and they kind of elicit or evoke ideas about the meaning that we can maybe understand as listeners, even if we wouldn't necessarily know for sure that's what it means. It kind of reflects that particular meaning. So these are sound symbolic in lots of different ways. There are whole Japanese scholars who dedicate their work to understanding these words. But I just want to point out that you can see that each of these words is repeated. And I think each of the meanings reflects some kind of continuous event, right? So something rolling, it happens continuously. Feeling impatient, it's waiting for something, it's a continuous process. So even in not just in the sounds that are used here, but also in the fact that they're repeated, kind of evokes a meaning. So there's lots of really interesting things you can kind of do with these words. And I've linked to actually this relates to the lead-in task too, and you can see that there's a dictionary of these words online that you can look at if you're interested. So I mentioned earlier that that I would return to the theoretical aspects of these because for sound symbolism to support early word learning, as is proposed by the sound symbolism bootstrapping hypothesis, infants need to be able to make these associations themselves, right? They need to, they need to be able to associate a spiky shape with a kiki and a booba with a rounded shape with the word booba, sorry. And so we know that they can do that from about 4 months of age. So from 4 months of age, they're already sensitive to these kinds of correspondences. That's been shown not really consistently, but in a few different ways in the literature that makes it like quite a compelling argument towards infants having a very early predisposition to these words. So we could propose that infants are biologically, they are biologically predisposed to understanding the sound symbolic links in their input. So we know that 4-month-olds can make these associations. We might say that it's innate, but I personally would encourage a kind of a different way of describing that relationship. So we typically wouldn't refer to nativism here. It's not something that I think is very prominent in the very early development literature, but we might instead say that it might be biologically determined, that might be something about these words that we just know from very early on, and that could come from our kind of physiology or very early womb-based experiences perhaps, or something else. It also could be learnt from the input. And this is the focus I'm going to take today, but we will return to these questions later on. But if it's learnt from the input, then it would need to be true for all different languages. There'd need to be sound symbolism in lots of different languages for babies of lots of different languages to be able to make these associations. So that's fine for babies learning Japanese, who have lots and lots of sound symbolic associations in their early environment. But we might think that that's probably not true for babies learning English, for example, because English is not rich in sound symbolic forms like Japanese, right? We have some words that we might say are sound symbolic or onomatopoeic, but they're not that common in our day-to-day lives. So, in our research, we wanted to find out whether or not sound symbolism is actually available in the early input for infants to learn, and therefore to support word learning in English. As I've already said, English is not rich in sound symbolic forms like in Japanese, but we can look at other properties. So we don't have lots of sound symbolic words in English, but we do make lots of associations between pitch and size. So size sound symbolism might be a better way to kind of focus in on this research question. And we also know that even from very early on, I think again about 4 months, I think probably just as a side point, the reason that 4-month-olds come up a lot in this question is because it's quite difficult to test babies who are younger than 4 months. So at 4 months, you can bring babies into a lab a bit more easily, have them sit up in a chair-ish, have them look at a screen for an extended period of time, and younger than that, it just is more difficult. So they may be able to do it earlier, but from about 4 months, we know that they can do it, and they can also make associations between pitch and size. So if you show babies a very small object on a screen, they will associate that with a higher pitched sound. And if you show them a picture of a bigger object on the screen, they'll associate that with a lower pitched sound. So, what we wanted to find out was whether or not English-speaking mothers use size-sound symbolism when producing object labels in infant-directed speech. And this would help us understand whether or not these cues might be available in the early input to help babies learn. So just as a reminder, this is returning to a talk I gave in the English Language Toolkit in 2019. Infant-directed speech is the concept where certain features of caregiver input when directed to children are more salient. So that is, they stand out more from parents' speech. This might be what we might call this baby talk or motherese. So it's a way of speaking to babies in a way that makes certain words stand out more. And we know that this probably supports word learning, at least for English learning infants. And when I use the word salient, I mean it stands out from the speech stream, and it's in baby talk, the ways that we make a word stand out are by producing it at a higher pitch. So, here's trying to think of an example off the top of my head. Oh, aren't you a beautiful baby, right? So we go in a higher pitch when talking to a baby than when talking to an adult. And I know I do that with my cat. I go straight up into a really high pitch. So I use pet ease with him all the time. Wider in pitch range. So again, in my example, aren't you a beautiful baby, right? So it's got this like sing-song characteristic to it. We also produce words more slowly in a way, so they're longer in duration. So like baby versus baby. Okay, so they're longer. And we may, so these three properties we know have been shown experimentally to attract and hold babies' attention. And then we also might produce speech more loudly. We might produce more words repeatedly. And we also might produce words in isolation. So that's when words are standing on their own without any words around them. So for example, we might say, look at that lovely doggy. Doggy, right, if you're looking at a book with a baby. So there we have the repetition of the word doggy, but also the doggy is produced in isolation right at the end. There was a pause before I said the second doggy. And these words, these features are known to help babies extract words from running speech. Because when we speak, we don't put finger spaces between our words, right? So continuous speech stream, and babies can't necessarily figure out where a word begins and where it ends. And these properties help babies make those decisions about words, where they begin and where they end. And I also want to flag up here that based on this research, we know that pitch is a really important feature of the input for babies. It draws their attention in, it helps them learn, it holds their attention. So therefore, it's we feel there's a good basis actually for looking specifically at size, sound symbolism and pitch in particular in our study. So, how did we go about designing our research? It ended up being, we thought we had a very simple question, and it ended up becoming quite complicated because of lots of different sub-questions that we ended up finding out as we were trying to figure out how we would run our study. We wanted to address the research question as clearly as possible. So we wanted to create a study that would really tick lots of boxes and not leave us with more questions unanswered than answered. We wanted our data to be ecologically valid, which means that we wanted to reflect real-world learning environments for babies. We didn't want to bring babies to the lab and have a really unrealistic situation be presented to them, and then have that somehow infer that we know something about how mothers speak to their babies. So we wanted it to ideally for the data to be collected in the home, in a situation that was natural for parents. So ecologically valid means that it reflects the real-world learning environment. Many experimental studies don't reflect the real-world learning environment simply because we have to have babies in a research lab. We have to present them with things that they've never seen before and will never see again. So this was supposed to be something quite realistic. But at the same time, the thing that you give up when you try to design an ecologically valid study is experimental control, which makes it difficult sometimes to address the exact questions you're trying to address because there's perhaps extra noise in the data that you can't account for. So we wanted to create a study that was both ecologically valid and as tightly controlled as we could manage. We also pre-registered our study, which is becoming a kind of an increasing thing that people do certainly in developmental psychology, where we we submit our research plan to a journal before we actually do the research. So before we collect our data, we decide exactly how we're going to collect it, exactly how we're going to analyse it, and exactly what we think we'll find. We send that to the journal, and they give us some feedback. We go through the review process, and then they hopefully, which they did with ours, they accept it, and they commit to publishing that paper when you've collected your data. The reason we do this is to ensure transparent reporting of research findings and avoid publication bias towards results that are only significant. So significant results are when you run a study and you find a clear difference between the groups that you're testing. So typically we read studies and we find that they found out a thing, right? We listen to, so they found a difference in the two things that were being compared. The problem is that if you run 10 studies, all testing the exact same question, using very similar data, at the moment, there's a tendency in research to publish the ones that end up showing significant results. So of those 10 studies, if there's one that finds a significant difference between two groups doing a thing, and 9 of those studies find no difference at all between the groups doing a thing, it means that the one that shows the difference will be published and the 9 that don't will not, which means that we think that these groups do a thing, when actually 9 times out of 10 they don't do a thing, and we don't know that because that's not published in the literature. So what a pre-registration does, and this is, you can maybe see there, it says their registered report, so it's the journal declaring to its readers, this was agreed on before the researchers actually did the research. What it means is that if we don't find a significant result and our results are completely boring, they'll still publish it and people will hopefully still at least glance over it, if not read it in full. And that means that we're then understanding that we don't always find what we think we're going to find in the data. So I wanted to say a bit about that just to explain the process of going through the pre-registration. Before we actually discuss the research design, I thought Sam had a great idea that it might be fun to kind of do a bit of a pre-registration today with you as our parents and children doing the actual task. So let's have a go at the task and see if we can come up with our own predictions. This might not go that well, but hopefully it will at least demonstrate the task, if nothing else, because you might, well, I'm not going to say anymore. So I'll show you the task, and this is actually extension task 1. So this is something we set up that could be applied in classrooms, and you'll have access to the materials from the experiment as well. And then we'll discuss what you might or might not have found in the data, and then I'll show you the actual results and tell you what we actually did. So the task was that we sent some books and posters to families, and we said, please talk about the toys in the materials in any way you wish. Just make sure you name all the toys that you see. So remember I said about this task being ecologically valid? We had to keep it as vague and general as possible, but also we really needed the parents to name the toys. So we did have to ask them to name the toys. Parents often do label objects when they look at books with babies anyway, so it wasn't too different. So please imagine getting to pairs again, and imagine that one person is the caregiver and one person is the baby, and the person who's the caregiver should please do the task. And this is the stimuli. Hopefully you can see it well enough. If you can't, you're welcome to come and have a look, or just do the ones you can see properly. And I'll just give you a couple of minutes to go through task 1. We've got a couple more tasks to come after this, so we won't spend loads of time. And just notice what you're doing and how you're speaking. Pay attention to your voice. Okay, so just keep a mental note of that experience. You may have made some actual notes, which would be great. And then we'll move on to task 2. This should be a bit quicker because there's only 4 objects. This one, so I don't know how well you can see. So this one is, can anyone see what that is? Yeah, it's a lion, yeah. And then that one on this side is a cheese. Yeah, okay, so with that information, please go ahead and do the same task, but with this stimuli. Okay. Since there's only 4 objects, I'm going to move us on quickly from that one. And the next task, so do the same, but with task 3, please. So a few things to reflect on then. Maybe you can just give me, any thoughts are totally fine, but just to guide the guide the conversation a bit. Did you notice any patterns in each other's voices, particularly across the 3 tasks? Yes.
Definitely, if they were smaller, then generally a higher pitch, and then if they're bigger, so there was it a cow or something that was quite small in the first picture,
Yeah.
and there was a monkey which was much bigger, so it might be more like a King Kong type. The only one we said might be different was the chair.
Mm-hmm.
So although the chair was the biggest thing, I probably would have still done quite a high pitch because it's smaller than a normal chair. It's a child's chair.
Oh, okay. Okay.
That was the only one we sort of disagreed on.
Excellent. So we're going to come on to this. That's a really, really important point you've just raised. So we'll come on to that later. Great, thank you. And you've clearly, obviously I introduced the idea of sound symbolism beforehand, so I know I've planted that idea, but yes, great.
We did role play, we addressed talking about what we would have done with our actual children.
Okay.
So that involved like the bus would have automatically gone to the wheels on the bus.
Okay.
And kind of linking things associated. And the chair was like the IKEA chair that we had.
The classic,
So
yeah.
is that your chair? And the kind of pictures and questions around. You talked about colours, didn't you? Bring in the what's the repetition of colour?
Okay. And particularly for the previous one, obviously we've got these are bowls. I don't know how well you can put they're bowls. So, okay, that's great. Thank you.
We
Yeah.
wondered if there was a different pitch in different colours. So with high for yellow and low for green, which kind of were, I think, it's the table.
That is so exciting.
And I
Okay.
Blue is definitely lower than yellow.
Right, and there's some kind of like consensus on this, right? Yeah.
Can you repeat what people say for the people at home?
Okay, yeah, thanks. So there was an observation there that colours have different pitches, and that yellow would be higher pitch than green, which was a consensus across the table. I don't know if everyone else agrees with that. Like
Sorry, was that higher for yellow or green?
higher pitch for yellow, yeah.
Okay, someone in the chat said lower pitch for the yellow.
Okay, no judgment here. So, but, yeah. Higher pitch for green.
We had a yellow.
Green, okay, yeah. Oh, this is great. This is all really, really interesting observations. So, yeah, okay. And I'll just skip to just to save a bit of time. If your voice changed, why or when did your voice change? There were any points in which you maybe changed maybe the pitch or just the way you spoke in any way?
There was one with the lion, it was a lower pitch, it was softer.
Okay.
Sort of raw, rather raw.
Okay.
Sort of the depth of the voice is softer, a bit quieter.
Okay. So you might have changed your pitch to actually refer to specific attributes of that
Yes.
object. Okay.
I think that
Yeah.
happened with the ball and the balloon as well.
Okay.
The balloon was longer, like elongating the word.
Okay. Great. Thank you. So keep a note of what everyone's said. People have made good observations about use of vowels, so the ball versus balloon to make the word longer, different colours, and other properties of the objects which may be relevant. Okay, so now we're going to look at the actual data. Sorry, I'm just going to get my notes up. So, as a reminder, our question was, do English-speaking mothers use sound symbolism when producing object labels in infant-directed speech? We were planning this study and we came up with a problem which has been already raised today, which is that sometimes children play with objects which are much smaller than they are in real life. And other times they play with objects which are much larger than they are in real life. So there's a kind of confound in, or a confound in potential confound in the data, where if a baby's playing with a toy car, it's very small, but it's referring to a very large object. And if a baby's playing with a large, what was it? A large piece of cheese, it might be smaller in real life. That's not a very good example, but just off the top of my head. Okay, so our research questions were as follows. First of all, do mothers encode size, sound symbolic properties in speech addressed to their babies? Does this phenomenon occur in infant-directed speech at all? We predicted, I think we've collectively sort of agreed, that mothers will produce a higher pitch in reference to smaller objects and a lower pitch in reference to larger objects. But given this confound that sometimes babies play with objects that are not true of their real-world size, we also wanted to ask whether size expectation of the object affects this size sound symbolic encoding. We couldn't make any predictions here. We didn't know if, when referring to a small object like a toy car, they would use high pitch or they would use low pitch to represent the fact it's large in real life. And you may have noticed that the contrast between size got more obvious across the three tasks. So in the first task, there was no obvious focus on size. In the second task, the paired objects were, one was big and one was small. And in the third task, they were exactly the same objects, except one was much bigger than the other, apart from in the coloured thing, which I'll come on to. So we predicted that when the size difference is more obvious, the pitch differences would also be more obvious, and that might be a useful cue in mother's speech. To test this, we tested 40 mother-infant dyads with babies aged 14 to 16 months. We originally planned to do this study in person, but then COVID happened, and we created a COVID-friendly study instead, where we sent materials to families, and we actually just had them, so we had a poster and then 2 books, and we had them record themselves on their phones and then send the recording back to us, which actually worked really well. We then analysed the stressed vowel in each of the target words. So, for example, in balloon, we measured the oo vowel, and in monkey, we measured the vowel, and we compared the mother's pitch in the different large and small contexts. So, as a reminder, we manipulated object size, so we had larger and smaller objects. Transparency, so how obvious the contrast was, so least transparent, mid-transparent, most transparent, and then our real-world size expectation. So either the expectation was congruent, so we had a small object representing a small thing, or a smaller object representing a smaller thing, I should say, or incongruent, where we had a larger object, this is an example here, a larger object representing a smaller thing. And I'm going to, I've just basically talked through this. I'm just going to really whiz through this so we've got some time for questions at the end. But we had, the poster was the least transparent condition, the paired objects were the mid-transparent condition, and then this is the obvious contrast between size here. Oh, and I should add about the bowls. Why have we got the bowls? We were trying to think of a control condition so that it wasn't just that mothers might change their pitch when looking at identical objects, but instead they only change their pitch when looking at objects that were different sizes, right? So we wanted to control for the fact that when you're looking at 2 different objects, you might actually have 2 identical objects, you might have a really specific pitch, pattern that you use. So we chose colour as a contrast, and the reviewer said, but there may be a sound symbolic relation between colour and pitch. How do you know? And then I think typically people have said yellow is a higher pitched sound. So we acknowledge that isn't actually completely irrelevant to sound symbolism, that pitch and colour may be related. And we can see what the parents did in the different conditions and see if they actually did that in a second. So I'm going to show you our results now. In the graphs, the round dots relate to pitch in the large when labelling a larger object, and the triangles are the smaller object. If it says NS over the top, it's not significant, so there were no meaningful differences in our data in the 2 conditions, and if there's a little asterisk, there was a significant effect. So we'll start by looking at the poster condition. We've got the mother's mean pitch on the y-axis there, and then we've got our congruent condition and our reverse condition along the x-axis. So that is where a congruent would be a small mouse and a large bear, and incongruent would be a large mouse and a small bear, as an example. But hopefully you can see here that those dots, the circles and the triangles, are all pretty much the same across the graph. So mothers are not really adjusting their pitch in the poster condition, the least transparent condition, to refer to different sized items. And this was, unsurprisingly, based on the graph, not significant. So that was that contradicted our hypothesis. In our second paradigm, which is where we had the mid-transparent objects, where the size was obvious in the books, but it wasn't obvious we were testing size specifically. Again, we found that the mother's pitch was pretty much consistent across. So basically they labelled all the objects at around the same pitch, regardless of whether it was large or small, and whether it was reflective of its real life size or its kind of opposite of its real life size. And again, this was not significant. Interestingly, and I will return to this, there was a significant difference between pitch across the two tasks. So mothers had a higher pitch in the second task than in the first task. Then finally, in our most transparent condition, we found a difference. We found that mothers referred to, oh, that's the wrong way around, the picture's the wrong way around, but the larger objects were referred to with a lower pitch, and the smaller objects were referred to with a higher pitch. So that is what we predicted, and that difference was significant. Looking at the colour condition, so actually mothers did produce the colour yellow with a higher pitch. So they labelled the yellow bowl with a higher pitch and the green bowl with a lower pitch, but that wasn't significant. That's just an interesting trend in the data. That there seems to potentially be some kind of assumption that yellow might be higher pitched than green somehow. So if we refer back to our research questions then, do mothers encode size, sound, symbolic properties in speech to their infants? That was our main research question, and we found that this was not a reliable trend in our data. Mothers only used size, sound, symbolism when the size contrast was highly transparent. So when two objects were exactly the same apart from size, and they wanted to maybe tell them apart in some way. Does size expectation of the object affect this encoding? We did not find this in our data. Whether or not the object was small or large in real life, that didn't affect the way that mothers used pitch in their voice. Sorry. And does the effect differ according to obviousness of the contrast? This was where we did find a difference. So mothers did seem to produce smaller things with a higher pitch when they were paired with something that was exactly the same, just smaller or bigger, just bigger, sorry. So, what do these findings tell us? Can we actually address some of the questions we had based on what we found here? So we find that there isn't this reliable encoding of size, sound, symbolism. So it may not be useful when learning object words more generally. So if we think back to the size, sound, symbolism bootstrapping hypothesis, try and say that very quickly, we don't find support for that here. But we do find some interesting findings that might give us some indication of some use for size, sound, symbolism in speech to babies. So the fact that we found this cue when the objects were the same, apart from size, suggests that it might be a useful cue in ambiguous contexts. So when the mother is trying to kind of tell apart two different objects or items. And we only looked at nouns, so we only looked at those object labels. But the mothers also produced lots of adjectives, and we were talking a bit earlier about additional things that we might say around the object word. We found that they used adjectives quite a lot, and we haven't tested it, but this is a really good area for future study because we may find that when mothers are producing the words small or tiny or little, they do use a higher pitch and a lower pitch when using like big tiger or look at the giant piece of cheese. So that might be useful. That might be an interesting area for future study. And actually that has been found in adult speech in previous work as well. And this would be really useful when learning more abstract words, right? So tiger and the word tiger and the object tiger are kind of, you can point to it, you can indicate what it is. It's kind of, there are multiple cues you can use to indicate what you mean by tiger. Whereas the idea of small is actually much more difficult for us to get our head around. You can't point to small, you can't demonstrate what small is in an easier way. So using these cues in speech might help to do that. And note that the mothers increase their pitch across tasks. I don't think that has anything to do with sound symbolism whatsoever, but it might be indicating that mothers are trying to hold their baby's attention across the two tasks. Again, indicating that parents use pitch in a way to maintain baby's attention and kind of engage them in a task. And that's also interesting for our understanding of how child-directed speech works. So to refer back to the theoretical perspectives then, how might sound symbolism support early word learning, given that we know babies do actually understand sound symbolic cues very early on? How might they learn these cues? Could it be biologically determined? So I actually can't think of any ways in which it might be biologically determined unless we just assume it's innate and there's a pre-programmed part of the brain that assumes that something small is produced at a high pitch and something large relates to a low pitch. I don't find that argument very convincing, especially when we consider the ways in which pitch and size are kind of so present in our environments in general and also in the early environment. So while mothers might not produce lots of pitch size cues, like related cues in infant-directed speech, there are loads of these cues available in the input. We started with the task of animals and thinking about the sounds that animals make. Smaller animals make higher pitched sounds. Larger animals make lower pitched sounds. That's true also for humans, and it's true also for objects. And so there are consistent cues in the environment that relate pitch and size. So infants might pick up on some of these, they might pick up on all of these. They may not be consistently present linguistically, but they may still be able to learn from these associations. So again, another interesting area for future study. So that is everything from me. There's some time for questions, I think. So thank you very much. These are my lovely collaborators who also were co-authors on the project. And also we've got thank you to the University of York that funded this research and colleagues elsewhere who advised us on it. And thank you for listening and taking such enthusiastic part in it as well.